Let me get this started because otherwise I'll forget. Okay, looks like that's showing up. Then actually tonight we're doing Q&A.
Oh, can we ask about homework problems in the Q&A?
I would kind of like to squeeze one more topic in, but it's not a good idea. You know, that's a temptation for teachers to avoid. Cram in some more right at the end. And then the students always, well, they do the only thing they can do. They cram too. And then they take the exam and then they forget. So, okay, what's the original equation?
So y double prime plus 9y equals 8 sine t if t is between 0 and pi, and 0 if t is greater than pi. So I thought
okay.
that turned into 8 sine t minus u of t minus pi times 8 sine t. And then taking the transform of all that just looks very ugly.
Yeah, so officially it is this. Let's see, u t minus pi times, and then you subtract off what you want to get rid of, right? The problem is that we know how to transform this.
But when the initial condition is y of 0 is 0 and y prime of 0 is 4.
So the catch here is that this doesn't quite match the theorem. So I would like to write sine of t in terms of sine of t minus pi.
Oh, I saw one thing in the 311 that said the transform of u of t minus a times f of t is e to the negative as times the transform of f of t minus a. That's what I was going with.
You were doing, you want to say it again, please?
The transform of u of t minus a times f of t is equal to e to the negative as times the transform of f of t minus a. Or little f of t minus a.
Yeah.
Oh, so yeah, I guess that would be the big F.
I think that's not true. Where did this come from?
311.
In the notes I handed out? Oh, good.
That is certainly possible.
This
wrote it
should
down
be
wrong.
t minus a. Well, I'm not above making an error when typing, but let's see.
Probably too faster than me.
If I can get this to cooperate. So let's see, that would probably be about,
Near the bottom. Hard to believe.
in here maybe?
Mhm.
Let's see, it's, this one right here.
Mhm.
Oh yeah, for discontinuous functions.
Right in there, equation 4. Oh, f of t.
Oh, notice the plus a here.
Oh, yeah, I wrote that as t minus a.
Yeah, that probably is true. A little awkward, but
It seemed the best thing to use since we have 8 sine t.
Sure,
There's no
sure.
omega on there.
let me show you this is the basic formula right here. So let me show you how to make that one work. Okay.
You just subtract pi because then.
Yeah, it flips it over, and then you multiply
something.
by -1, and you're good to go.
Yeah.
So I guess this is okay here.
Well, just when I took the transform of all that, then you get e to the negative pi s times 1 over the quantity like s plus pi squared plus 1. So that didn't look very
Yeah.
fun.
Okay, so let's.
So good. There's a perhaps simpler way.
Yeah. Now, whether it's going to make things nice, I don't know. Okay, so what I would recommend is this. The sine of t minus pi is the same as the negative of sine of t. So sine of t is equal to minus sine t minus pi. Therefore, when you take the transform of this left-hand side, you'd write it this way. And let's see, I guess you need an in here as well, right? Otherwise it won't add out. Okay, now, just to be careful, when t is on the interval, good evening, on the interval from 0 to pi, then we're just going to get this, 8 sine t, which is what we want. And once we cross that boundary at pi, then this turns into a 1. And this turns into sine of t minus pi, which is the same as minus sine of t. So you get 8 sine of t minus 8 sine of t, which is 0. So it appears that will work. Okay, so to transform the right-hand side, this
You
is
just
going to
factor out all those 8s.
Yes, you can. If you like it that way, put it on the outside. Then sine of t has transformed 1 over s squared plus 1 squared officially, but that's all the same. And then this one is going to be e to the minus pi s over s squared plus 1 squared.
The s doesn't come from t minus pi.
It comes from the formula.
I'll be right. The t minus a becomes just s.
Yeah.
For f of t.
Right. Your variable changes from t
Okay.
to s. Oh, that's not really showing. Okay, so That's the transform of the right-hand side, transform of the left-hand side. Y double prime plus 9y.
Yeah, that already looks much nicer.
Good. Okay, now we want minus sy at 0, which is 0. Minus y prime at 0, which is 4. Plus 9 cap y. And that equals this thing on the right side. And I think I'll write it this way. It's easy to take it back apart later. We probably will want to, but I have limited room here. And that's an S, not a 5. Can I agree? Okay, so I want to solve this thing. So I have S squared plus 9 cap y is equal to, let's see, I put this 4 on the other side. 4 plus 8 plus e to the minus pi s over s squared plus 1. And then divide through by s squared plus 9. Wow. Okay. Intense algebra here. I think what I would do probably is split this with partial fractions. And actually, I think I see exactly how to do it.
And how to factor out the 8 from e to the negative pi s.
Oh, let's see. Is that supposed to have an 8 on it? Or yeah, it is. Here it's got an 8. Oh,
right.
it lost it here. Tisk. Okay. Okay. That's interesting. It went away and then it came back. Nice one. Errors cancel out. Okay. In this, just by good luck, I know how to split that with partial fractions just by looking at it. Because I just observed that the difference between 9 and 1 is 10. So 9 and 1 is 8. So I want 1 over s squared plus 1 minus 1 over s squared plus 9. Now, when you put this back together, you'd have s squared plus 9 minus s squared minus 1. So the s squareds add out. 9 minus 1 is 8. You get that back. And then we're going to have to, what we're going to do is take the transform of the stuff in the brackets there and then transform it again with this vector. So can I get that all worked in this little tiny space? Maybe. Y at t. Okay, inverse transform of this. Well, what I really want on the top is a 3. So I'll write this as 4/3 times that with a 3 on it. And then 3 over s squared plus 3 squared is the transform of sine of 3t. The inverse transform of the left piece in the bracket here is sine of t. The inverse transform of the thing on the right is minus a third sine of 3t. I think, let me just double check. Yep, looks okay. And then we want this thing again with a shift by pi on it. Plus u t minus pi. And it's going to be hard to get that in. Teeny tiny writing. Sine t minus pi minus 1/3 sine 3 t minus pi. And then there should be a bracket which won't fit. And you might notice 4/3 minus 1/3 is just 1. So this is sine of 3t plus sine of t plus that function with the unit step function on it.
Well, thank you.
You're welcome. I hope that helps.
I think that saved me a couple hours or so
Okay.
of scratching.
All right. Let me pause to say hello. Okay, there we go. Welcome, everyone. In case you didn't know, we're back under the mask mandate. So that's the way it is for now. And presumably that won't change by exam day, which is 1 week from today. So please remember to bring a mask or be willing to use the ones that are here. There are some of these blue masks around here. So if you forget, you're certainly welcome to use one of those. Tonight, really, there's not much on the agenda other than answering questions and just going through a couple of announcements. First of all, the final exam is 1 week from today here on campus in Applied Technology Center, room 231. I will be here myself and ready to administer exams by 5:30. And I'm willing to stay until 8:30. So that's actually a half hour on either side of the official time. So if you would, I know some people have issues with like jobs. If you get out of work at 5 or 5:30, it could be hard. If you've got a ways to drive, it could be hard to get here on time. So I'll be staying a half hour over. Some people don't, as far as I know, no one in my class has officially accommodation for disability, but sometimes that's because people are visiting us. They have them at their other school. So if you really want the extra time, you could come at 5:30 and stay till 8:30, and you'll have 3 hours instead of 2. You don't need any special permission to come early or to stay late. You just show up and leave when you're ready to go. And you don't need any special permission to stick to the regularly scheduled time of 6 to 8. It's just when I'll be. So feel free to work that out as seems best to you. I have not yet graded assignment number 12. And the reason is I spent the time I had available doing two things. Actually, I spent a very long time making some video lectures to replace the video session that we didn't get last week on Thursday due to technology failure. But there are videos there now. And then I also spent a fair amount of time working out the problems in the homework assignment number 13, so that I would be aware of any issues that are possibly out there. And I'd be well prepared to answer questions efficiently tonight. So that really is the extent of what we're going to do tonight. Is I'm going to answer questions, and when we run out of time or we run out of questions, we'll quit. So does anyone have a question they'd like to ask? By the way, if you're attending online, I'll be trying to remind myself to check in on the chat window. So you can ask a question that way, or you can just talk. So next.
I had a question.
Okay, shoot.
Number 9 on 3.9 or 5.1, that problem set.
Okay, let me see if I can. Find it. Okay. It's which number would you like to see?
Number 9
Okay.
from 3.9.
All right. Let me see. I gotta switch cameras here. Okay, so that's this guy right here. Yeah.
Yep, that's the one.
Okay. This is a homework problem that's coming up. So I think what I'll do is I'll give you an example of something very similar, but not quite. So that'll leave you something to do for this particular problem. The original problem just had a line segment from one high and one to the right. So let's just do it a little slightly differently. How about if I intersect here at 2 and intersect here at 1? So this is very similar to the one that's assigned. All right, so you can skip this step if you want, but some people find it helpful. Let's write this first in sort of the way that we did in calculus. And I would say, first of all, I would figure out, well, this right here, this thing is a line. So it's y equals mx plus b for some values. The slope, the rise is 1, the run is 2, and it's negative, so minus a half. And I can just see straight away that this is going to zero out at 2. So x minus 2 will probably do it. Let's just double check. When x is 0, then I have minus a half times minus 2, I get 1. That works. When x is 2, then this is 0, and it doesn't matter what that is. So I get 0. And that seems to be working. So I got minus a half, x minus 2, if 0 is less than x is less than 2. Doesn't matter if you put equality on here or not. It's not important for these, for computing transforms. And then after that, it's 0 if x is more than 2. So f of t, we want to write that now as a single expression involving unit step functions. So I would say that we're going to start with the equation of that line, minus a half x minus 2. And then when we get to x equals 2, we want to subtract that back off. Now that was a negative. So when I multiply those two negatives, I'll get a positive. And this is actually fairly convenient because we got an x minus 2 in our function and we got an x minus 2 in our unit step function. And that will help when it comes around to writing transforms. Now, I don't know, did it ask for a transform or not? Yeah, it did. So last thing, let's see. I think I'll not do too much simplification because it'll probably just make the transform harder. Okay, so, oh, that's interesting. I said f of t and then I wrote x's. Well, x or t, it doesn't make any difference, whichever you like. So I think I'm talking to Micah, right?
Yeah.
So are we good so far on this one?
Yep, I follow.
Okay, so now we want to find the transform of f, little f. And I would just transform this first one a piece at a time. I've got minus 1/2, and then the transform of x or t is 1 over s squared. And the transform of minus 2 is minus 2 over s. Then this has the form, I'll just kind of write it off to the side here. Laplace transform of ut minus a, f at t minus a. And the transform of that is e to the minus as f at s, where cap f is the transform of little f without the shift. So I want, well, I need the 1/2 because that's a coefficient here. And then e to the minus 2s times the transform of x minus 2. Well, I want the transform of x because the shift goes away when you take the transform. So the transform of x is 1 over s squared. So there it is without any cleanup. I suppose you could do some algebra, make it look a little better, but essentially that's it. Does that help?
Yeah, thank you.
So of course yours is going to be a little bit different. You know, this is going to be different. Those are going to be different. That, whoops, right here. That shift is going to be in a different place, but it's more or less going to look like this when you do the calculations. And looks like I started using this for some purpose. Never did. Okay, any others? This is 3.9, number 9.
I didn't do work from because I was from for I didn't realize that it's by trying to solve it by turning the cosine square into a 1/2 plus 1/2 cosine of 2 times the argument. And if I checked the solution, it came up right, but I was just wondering if that is the case.
Yeah, the question is this, if you were trying to compute, I think it was this, right? The question is, I gave a hint and I said, let this thing be equal to f, then take its derivative and use the formulas for the transform of the derivative. Second option is, well, couldn't you just use a trig identity to knock down the power? And the answer is yes. I think cosine square omega t, isn't that equal to 1 plus cosine omega t over 2 or some such thing? Is that the one you were using?
1/2 plus 1/2 cosine of 2 omega t.
Oh, 2 omega t, yeah. Change colors. So sure, absolutely, you can do it that way. And it should give the same answer.
It did. I was
Okay.
just wondering if that was always the case or, by chance it just so happened
As
was possible to solve that.
As long as you're using a valid trig identity, it should be just fine. Yeah. Yeah. And that's actually one of the things we should expect to work. In mathematics, it's very often there's more than one path to get where you want to go. And they should all generate the same result. If they don't, something is wrong. Now, there's all sorts of things that go wrong, like, forgetting the 2 in the identity. But otherwise, it should work, yeah. By the way, it's not so terribly different. What I suggested in the hint was this, to let f of t be this guy.
Could you skedaddle the paper a little bit, please?
Yes. And then notice if you take its derivative, and then I also used a trig identity and also got the same argument that you did. So then I use various things will occur in here involving the transform of sine of 2 omega t. And I won't give the details because it'll ruin the fun for you. But your way is fine. You don't have to use that. No. This, by the way, is a standard trick for generating new transforms. Try the derivative formula, or try 2 derivatives. In the case of sine and cosine, oftentimes 2 derivatives are just what you want. It will wrap you back around to the function you started with. Okay, any others?
Could you maybe go over how to do something like number 1 from 310?
Okay. Sure.
Maybe you know an easier way than me.
My recollection is that this one is remarkably challenging, given how easy the equation is to solve by formulas. So the question is, could I go over how to handle something like 310 number 1? And let's see. Switch cameras here. 310 number 1 is this. Y prime plus 3y equals 10 sine t, where and y of 0 equals 0. So why don't we just modify it a little bit? Oh, I don't know. 10's not so bad. Now, if we wanted to solve this thing, it actually doesn't require Laplace transforms at all. This is a first order linear equation. So we have a formula that says if you have y prime plus p of x y equals r of x, then its solution is y equals e to the minus h times the quantity integral or antiderivative really e to the h r of x dx plus any constant. And then we would fix up the constant by imposing this condition that y of 0 equals 0. And of course, number 1 is not quite like this. There's some different numbers, and there's a sine instead of a cosine. The one thing to notice is if you do this, h is an integral of p. And in this case, the coefficient on y is just 5. So that's 5x. And this thing in here is not especially friendly. It's not horribly difficult, but it isn't really nice. The right-hand side is 10 cosine x dx. Now, I'll tell you what I did, because I did work it out this way as well as by Laplace transforms. So what I did is I just opened up my web browser, went to Wolfram Alpha, and I suppose I could have just asked it to solve the differential equation, but I typed in the formula and I got their result. And it's, machine generated answers, oftentimes they're a little bit messy, and I don't remember if I had to do much cleanup on it or not, but probably some. And then I compared it to what I got using Laplace transforms. So we know it's going to involve this, and you could tell by the form, you would expect something times e to the minus 5x. Perhaps that c will turn out to be 0, so that you might not see that. And then when you integrate e to the 5x times a cosine of x, typically you're going to get an e to the 5x times a cosine and an e to the sine x times something involving sine. And then when you multiply through by the e to the minus 5x, it'll kill those off. So you're kind of expecting something involving sine, something involving cosine, and possibly a pure exponential term. So we know generally what to look for. And honestly, we could probably guess the answer easier than we can solve it with Laplace transforms, but it's still good practice. So what we want is to transform this and to transform this. And keep in mind, since I just sort of made this up, it could get really messy. If it does, we'll probably just bail out. But I think it's not too bad. All right, now transform of y prime is s cap y of s minus y at 0. But y at 0, of course, is 0. So that term's going to drop out. Plus 5 cap y. And then I want the transform of 10 cosine t. Well, cosine t has transform s something over s squared plus 1 squared. And cosine is even, so the transform is odd. That'll be an s. And now I need to take into account the 10. So far, just like that. This term mercifully is 0 in this case. So I got s plus 5 times cap y. And if I divide both sides by s plus 5, I have this very friendly looking fraction. Like so. Now, I think the best way to handle this is partial fractions. I would have to think about it for a while and see if I could imagine another way, but the standard way is partial fractions, and it'll probably work pretty well. Okay, so we're expecting to split this into a fraction with some up to first degree. It could turn out that a is 0, but up to first degree numerator over s squared plus 1 plus a constant numerator over s plus 5. Okay, so we just put those two fractions back together. When we do, we'll get this denominator again. So then we'll equate numerators. So 10s is equal to as plus b times s plus 5 in parentheses plus c times s squared plus 1. Now, there are lots of things you can do here. It actually works to do this. You can put s equals minus 5 in here, which will kill the a and the b, and you'll immediately figure out what c is. You can also set s equal to the complex number I, 0 plus I, and then do the same here and then equate real and imaginary parts. However, what I would say is if you're going to go to that much trouble, then with substitutions, you could have just as well multiplied this out and equated coefficients. So since it isn't so clear that we're going to save ourselves trouble by avoiding this, I'm going to multiply this one out. So I've got this term times this one is as squared. The s terms are b times s and 5a. And the constant term is 5b. And then this one is c times s squared plus c. And if you gather up all the like terms and spell everything out, you get this equation, 0s squared plus 10s plus 0 equals, now those two go together, a plus c s squared plus 5a plus b. Oh, sorry. So what I'm doing here, I don't know how much you missed. I'm just multiplying this out, gathering up like terms. So I've got an a and a c as coefficients on s squared, a plus c s squared, 5a plus b times s, and then constants are 5b plus c. Okay, so I get three equations with three unknowns here, which is it's not real bad, especially since we have calculators that will do this. A plus 0b plus c, taking the coefficient on s squared, equals 0. Coefficient on s, 5a plus b plus 0c equals 10. And 0a plus 5b plus c is also equal to 0. So I end up with this system 1, 0, 1, 0, 0, they're wrong. 5. Oh, this would be all right. I'm copying it in the wrong order, but it's just as good. So this last equation, 0, 5, 1, 0, 0, 5, 1, 0, and the middle one, I didn't switch these around for any good reason other than I just skipped a line. So I get that. And of course, it's equivalent to having that one at the bottom in the middle. Well, I don't know, is it? I don't, it isn't obvious to me. I will just solve the equation to come up with this. I see you're typing. Have you run it through the calculator?
No, I
Okay.
did it manually, but I want to check it.
Okay, so this one tells me if I'm just solving by hand, this is probably better. A equals minus C or C equals minus A. This one tells me that B equals minus C. Oh, look at that. Maybe if I had it the other way. I like that better. And this one tells me that 5A equals negative B. Okay, so, and A and B are, ooh, wait a minute. Is that true? This seems to say A and B are equal. But if that's true, oh, I'm looking at the wrong thing. Yeah, B is, then A and B are both 0. And that would be a contradiction here. So I guess I'm wrong. A equals minus C, agreed. 5B equals minus C. All right, so A equals 5B. Okay, so do we have anything that pops out now? No. Okay. So minus 5 times the top one, add to the bottom one. 1, 0, 1, 0. I was hoping for a quick trick to solve this, and it just didn't happen. Okay, I get a 0 here. I get a 1 here. Minus 5 plus 0. Minus 5 here. And I still got a 10 there. All right. About if I take minus 5 times the bottom one, add to the middle one. Then I'll have 0 and 0. So minus 5 plus 5, and then 25 plus 1, 26 here. And minus 50. Not such a nice number. So if I did this right, C equals minus 50 over 26. And well, of course, I just made this up, right? So there wasn't any reason to expect it to come out next. So then B, this says that B is equal to 5C. So minus 125 over 13, of course. And A is equal to minus C. Okay, so there's my solution. And that allows me to write this line right here without unknowns.
B should be 1/5 of C.
B should be
5 times B plus C, 0.
yes. Oh, I did 5 times. Like so?
How can you do that? Yeah, there you go.
Okay. Well, it's nice, but it's a solution. Y at S equals, we are referencing all the way back to that line right there, A times S. A turns out to be 25 over 13.
Positive, I think.
Plus B I don't remember using this equation. Oh no, look. Should be that, shoot. You know, I could muck around with that for a good long time. Only to wish I had done this, which I already do. Okay, and then what on earth? Oh, okay. Here we go. Well, I guess it wasn't totally wrong. A is 25 over 13. B is 5 over 13. C is minus 25 over 13. Okay, then cap Y is, we've got AS plus B. So over S squared plus 1. And then plus C. Over S plus 5. And everything was divided by 13. So I'll just take the 13 out. Okay, assuming now that we got everything set up right, we can take the inverse transform. Y at t is equal to this is supposed to be, I wrote a b here, I don't know why. It's S squared plus 1. Okay, so S over S squared plus 1 is the transform of cosine t, 1 squared, so I have a 1 here. So that takes care of 25s over S squared plus 1. Then the 5, that is cosine of t. And then we have minus 25. 1 over S plus 5 is the transform of e to the minus 5t. And everything in sight was divided by 13. So there it is. As promised, not that very convenient, but it works. And we did get pretty much what we expected, right? Wait a minute, hold on here, just hold on a minute. That's an even, so it comes back to an odd. And where I have cosine, I should have sine. Oh, am I looking at three? That's even, comes back to odd, yep. That's odd, comes back to even, yep. Okay. But that's what we were expecting. A cosine term, a sine term, and perhaps a pure exponential, and we got it. Ooh, I see people looking thoughtfully at the screen. All right. Piece at a time. $25, take that to the outside. S over S squared plus 1 is the transform of cosine 1t. Then the inverse transform of 5 over S squared plus 1. Factor the 5 off. 1 over S squared plus 1 is the transform of sine t. And then the inverse transform of 25 over S plus 5, factor the 25 off, and e to the at has transformed 1 over S plus a, so that you think of that as S minus the minus 5. And then you add those up and divide them by, don't drop minus signs, and divide by 13 and you get that line. Okay. Sam, you're looking thoughtful. Do you want to ask a follow-up on this?
When you're looking at it, and you're saying it's turned to even, or this turned to odd, what exactly?
Oh. The transform of sine omega t sine is an odd function. And its transform is omega over s squared plus omega squared. Now, if you replace s by minus s, you get the same thing here. So this is an even function. So I just remember that an odd function has transform that's an even function and vice versa. So if you change t by minus t, you get the same result here. This is even. If you replaced s by minus s, well, down here, it all cancels out, but up here, the minus sign remains. So this is an even function. And this is an odd function. And that's generally true. It's not just for sine and cosine. The Laplace transform of an even function is an odd function. And Laplace transform of an odd function is an even function. And the reason it does that is it's defined in terms of an integral, and integrals and derivatives have that. Take the integral or the derivative of even or odd, and you change the period. Now, if that doesn't help you, then, don't think of that if it's confusing. But to me, it's helpful. I remember generally that if I take the transform of sine or cosine, I'm supposed to end up with either s or omega in the numerator over s squared plus omega squared. So, and then that even odd thing allows me to remember, do I want an s or an omega? Okay, any others?
What was it that we used the initial value on this?
I'm sorry, I didn't.
Where did we use the initial value for this?
Let's see. Was it this one? The initial value is y is 0 equals 0, and that comes in way back here. It saves you, this term drops out. This would be even more complex. Suppose this were a 3, then minus 3 here would become a 3 here, and I'd have yet another fraction, which would, generate more stuff over here. It's not that nice to deal with, but the basic idea is not real complex. It's all the massive detail, at least for me, that makes this challenging. And then, of course, tiny little errors early in the calculation mean, oh, you get to do it all over.
I guess, could you talk a little bit more about some, like, the stuff in 3.11 or 3.11, as far as like combining the step function with other functions?
Yeah, the question is, could I talk a little bit about the kind of problems that we encounter in section 3.11 that combine the step function with other things? the primary thing that is going to come up. Now, I won't tell this exact one, but it's worth looking at. I think this one was assigned, right? This one.
Yeah.
When you take the transform of this, since the initial conditions are 0, you're going to have s squared plus 6s plus 8 times cap y, and then you'll divide by that. And these are going to transform to 1 over s plus 3 and 1 over s plus 5. So you just end up with fairly complicated fractions that you have to decompose by partial fractions. Now, where it gets a little bit different, okay, say on number 23, we're going to get a unit step function. And then its transform is going to involve e to the minus as for, well, e to the minus pi s. So when that comes up, then you have all the same kind of stuff to work through that we did here. If I could identify one of them. Suppose we have, let's just pick one of these things. You end up with something like this. Suppose you had 25 e to the minus, I don't know, 3t over s plus 5. And you want the inverse transform. What you do is you first of all ask yourself, now you don't have to write it this way, but it is one way you could write it, is you ask yourself the question, well, how would we find what would we have for an inverse transform if that exponential was not there? And the answer is 1 over s plus 5 as inverse transform e to the minus 5t. And then when that goes back in, you get u t t minus 3 f at t minus 3, where that thing is f at t. So that's u t minus 3 times f at t minus 3. Well, there's f. And that's a 5. So it's actually not a lot worse. You have this one extra step of once you compute an inverse transform, and then you put a shift on it with a unit step function. Now, it's easy to come up with examples to see that in action. Let's suppose we had this, not s squared, y double prime plus 4y equals delta t minus 7. And I just want a number that isn't anywhere else, so you can see, you can follow them around. Then when I take the transform, and to make it nice, I'm going to set the initial conditions to 0. If I didn't, I just get some extra terms, and you handle them in exactly the same way. So you'd have s squared cap y at s plus 4 cap y at s equals, this is e to the, I think it's 7s, right? I sometimes get the minus sign backwards. This would not be a good time to do that. I didn't write it down in my notes here.
I think it's negative a s e to the negative AS. What I wrote down last week.
Yes, that makes sense. Okay, so s squared plus 4 capital I at s equals e to the minus 7s. And now when I divide, so the way now we just need the inverse transform. So you do just what I said earlier. You first ask yourself the question, well, what's the inverse transform without the exponential factor? Well, what we'd like is a 2 up here. So we get it just like we do for integrals. And then this is sine of 2t times 1/2. And then put the exponential factor back in there. And that produces a shift in a unit step function in your answer. So if you have the direct delta function on the right-hand side, it just is going to produce a shift in the end. Now, if this had been a unit step function, it's a little more complicated. If this had been, say, ut minus 7, then this would be e to the minus 7s over s. So then I'd have s times s plus 4. And then I'd have to either split it with partial fractions or handle it with an integration.
Okay. Yeah, I was just like looking through the notes. I think I was having a little trouble following because like it seems sort of, I'm not sure how to describe it. Like with the step function, it's like two functions multiplied together, but you can't really take transform easily of like just two random functions multiplied together.
Oh,
Is
yeah,
that- you know what I
no.
mean?
Yeah, the Laplace transform,
Like you can do like sine over x plus 2 and just
yeah, if you
jam
take,
the separate Laplace transforms together.
yeah, there's no nice way to handle this. And yet, what we are saying is that this particular product has a predictable transform.
Is it just because it involves the e to the whatever power and that's
Yes.
integral of
Yes.
the Laplace thing?
Yes, exactly. And if you remember the derivation, you have this, and what you do is you set that equal to x, dx and dt are equal since the coefficients on x and t are both 1. And this then becomes x plus a. So you get this, then you factor off e to the minus a times s comes to the outside, and that's where that thing comes from. And were it not an exponential, it wouldn't work anything like that.
Okay, that makes sense. The whole step thing's just not quite intuitive yet, I think.
Yeah. Well, and in that case, you generally take it a piece at a time, like this. First do it without the exponential, then put the shift on it, and you'll probably get it right.
So if you have like an F and a G, like you've written down there, would it be a good idea to maybe see if like one of them happens to be an integral or derivative of the other? And try and solve
In
it that
general,
way?
there isn't any nice thing to do with this. It's the integral from 0 to infinity, e to the minus st times f of t, g of t, dt. Now, if you could, maybe, you know, you can do something with parts or something, I don't know, but we know that in general, integrals are just not all that easy to handle, right? If I can make up an integral that you can't evaluate, and you can make up an integral that I can't evaluate. It's not hard. You know, just pick something at random that's got lots of pieces, and we probably don't know how to do it. So there's just no nice way to deal with it. There is a related thing where you have f of, it's something like 0 to a, f at t, g at a minus t, e to the minus st. And this is called a convolution. And that turns out to be straightforward. It's f at s times g at s. And who would ever think? But it turns out to be nice. But that's because you're starting with something that's not nice. Okay, well, let me just check the chat box here and see if anyone else has posed a question. Okay, the question from online is this. For the final exam, will there be any questions on linear algebra? The answer is yes. The final exam will be comprehensive, and I think of this course as coming basically in 3 parts. Part 1 was linear algebra. Part 2 was basic differential equations. Part 3 was topics in differential equations, which included numerical methods, Laplace transform, and infinite series. So there will be some questions from each of those. Most likely it won't be quite a third, because on the first 2 parts of the course, I had a separate exam for asking those questions. So probably it'll be more like a half of it on this last unit. And then the other half will be questions from linear algebra and basic methods of ODEs. Next class period, I'll address that issue more in detail, but the short answer, Jack, is yes. Now, what I suggest for preparing for the final, you know, it certainly is late enough to be starting that. What I always did as a student myself, and it worked very well for me, was first of all, let's just start with an outline. I make a list of the major topics in the course. Then what I used to do, and you know, you can do this or not, whatever works for you, I would then pick example problems for each of those types. And, you know, I would work them enough until I got good at them. And I tried to get enough variety that it was reasonably representative of the sort of stuff we did for each of those topics. Then I started a process of distillation. So I might start with like a 20-page outline, which, you know, sounds like a lot, but actually, if you're writing out math problems in there, you know, it doesn't take that long it's not that many problems along with an outline, to occupy 20 pages. And then I'd ask myself the question, okay, can I somehow condense this outline? Not necessarily in a way that would communicate to anyone else, but that communicates to me what's in the course, and try to cut it like in half. Can I do it in 10 pages? And then once I did that, then I'd say, okay, well, can I write this in a way that reminds me, maybe no one else, but reminds me of everything that's in the course, and I'll get it done in 3 pages or 2 pages. And I kept at that process until I had one 8.5 by 11 sheet of paper that had cryptic markings on it, which no one on earth besides me at that point in time would be able to interpret. If you handed me one of those from my past, I'm sure I would have no idea what it meant now. But what the advantage of that was, first of all, I did get a lot of practice. But secondly, I walked into my final exams with an outline of everything that was in the course in my head. And then when I saw a question on the exam, I could quickly, it was like a mental filing system, you know, I could sort of run through the list. It's one of those. Okay, now I know that there's, 4 standard types or something. And it was great. And I did that for a couple of reasons. Number one, I wanted a good grade. And number two, I had this awful problem with dyslexia or something like it, which you yourselves have now witnessed many times, which made me prone to things like arithmetic errors or dumb things in algebra, things I know are not true. I would write them down. And so I had to be able to go fast enough so that I could not only solve the problems, but then go back and check my work. So my plan was to know it so well, I could get it done in enough time that I had time to check, or even to be able, maybe in many cases, I would know 2 or 3 different methods to solve a problem. So then I'd flip the exam over, solve it another way. Do I get the same answer? If not, well, why not? And that method worked very well for me. Now, maybe it won't work well for you. That was tailored for me, but it's still I think a good idea to start without an outline of the class. If nothing else, it will help you surface those areas of the course that you need to practice on. Okay, well, hearing no other questions, last opportunity. All right, that sounds like the end of it for tonight. Then I will, of course, we'll be having class on Thursday. And the major point of that is for you to ask questions relative to the final exam. And of course, if there was things that come up on the last homework assignment, that is relative to the final exam. So anything relative to the course, relevant to the course, you're welcome to ask. And I will see you then on Thursday. Have a great night.